There's a massive development unfolding right now. The kind of development that has astronomers double-checking their data and asking questions nobody expected to be asking.
Those images that were just released today, they don't show a cometary tail. They just show a blob of light, a fuzz of light around it, the way we saw when it was far away from the sun. And so the question is, what is this object?
On November 5th, 2025, NASA finally released fresh images of Atlas, the interstellar visitor that has been captivating and confounding scientists since its discovery. And what these images reveal, or rather what they don't reveal, has just deepened one of the most perplexing cosmic mysteries of our time. The expectation was clear. After Atlas passed perihelion, its closest approach to the Sun on October 29th, at a distance of just 203 million kilometers, where it was receiving roughly 770 watts of solar radiation per square meter, there should have been a massive cometary tail. That's what happens with comets. That's what the physics demands. When a comet gets that close to the Sun, when it gets heated that intensely, it sheds dust and gas. That material gets swept backwards, away from the Sun, by solar radiation pressure and the solar wind. It forms a beautiful, unmistakable tail, sometimes stretching millions of kilometers across space. But here's the problem. The newly released images show no tail, zero, nothing. Just a diffuse, fuzzy blob of light, exactly like what was observed when Atlas was far away from the Sun, out in the cold depths of space where comets are supposed to be dormant. This isn't a minor discrepancy. This is a fundamental violation of what should be happening. For comparison, take a look at images of Comet Lemon, taken by the same telescope just 2 days earlier. There's the tail, clear as day, exactly as expected. That's what a comet looks like. That's what the physics produces. But Atlas? It doesn't resemble that at all. And this leaves open a question that's becoming increasingly difficult to ignore. Why is this object behaving so differently from every other comet ever observed? Let's back up and review what's been happening with Atlas, because the missing tail is just the latest in a series of anomalies that have been piling up. When the object went behind the Sun, something changed. It got brighter. Not just a little brighter, but approximately 5 times brighter than before. It also got bluer, taking on a color shift that's unusual for cometary objects. Natural comets generally appear redder because they release dust and because their surfaces are cooler than the Sun. But 3IATLAS became bluer than the Sun itself. That's backwards. That's not what comets do. Then there's the acceleration. Tracking data showed that Atlas's trajectory deviated from what gravitational forces alone would predict. This is what scientists call non-gravitational acceleration. Something was pushing it, giving it an extra boost that gravity can't account for. Now, comets can experience this phenomenon naturally through something called outgassing. When the Sun heats a comet's surface, frozen volatiles sublimate directly from solid to gas. That gas jets out into space, and like a rocket engine, it creates thrust. It's a well-understood process. But here's where the math becomes a problem. To produce the amount of acceleration observed with Atlas, the object would have needed to lose somewhere between 10% and 20% of its total mass. That's billions of tons of material. When that much gas and dust gets ejected from a comet, it doesn't just disappear. It forms a massive, extended cloud, a bright, obvious cometary tail that should be visible for weeks or even months. The solar wind and radiation pressure don't give that material a choice. It gets pushed outward, away from the Sun, creating that characteristic tail structure. So where is it? Where are the billions of tons of gas and dust that should be trailing behind Atlas? The images show nothing. No tail, no extended coma, just that same fuzzy glow. It's as if the object somehow accelerated without producing any visible exhaust. For a natural comet, this makes no sense whatsoever. One potential explanation being discussed is that what evaporates from Atlas consists of very small fragments of ice or other volatiles that get vaporized by intense sunlight almost immediately before they have time to be pushed outward by solar radiation pressure. In this scenario, the material essentially disappears before it can form a visible plume or tail. It's a possibility, but even this explanation has problems. The amount of mass that would need to be vaporized so quickly, so completely, without leaving any trace, is enormous. And there's no clear mechanism for why Atlas would behave this way when every other comet observed doesn't. This isn't the first time Atlas has defied expectations. Since its discovery, this object has been accumulating anomalies at a rate that's starting to feel less like coincidence and more like a pattern. Let's walk through them, because when taken together, they paint a picture that's deeply strange. First, there's the trajectory. Atlas is traveling on a retrograde orbit, meaning it's moving backwards relative to the planets. That's not impossible for an interstellar object, but here's what's weird. Despite coming from outside the solar system, despite approaching from interstellar space, its orbital plane is aligned within just 5 degrees of the planetary plane. The planets all orbit the sun in roughly the same flat disk. That's a consequence of how the solar system formed from a rotating disk of gas and dust. But Atlas didn't form here. It came from somewhere else entirely. So why is it aligned so precisely with our planetary plane? The statistical probability of this alignment happening by pure chance is approximately 0.2%. That's 1 in 500. Unlikely, but not impossible. But it's the first red flag. Second, the timing. Atlas arrived on a trajectory that brought it past Mars, Venus, and Jupiter. But here's the remarkable part. When it reached perihelion, its closest approach to the Sun, Earth was positioned on the exact opposite side of the Sun. From our perspective, Atlas was hidden in the Sun's glare, impossible to observe directly. It's as if the object's timing was choreographed to minimize visibility during its most active phase. The probability of this scheduling occurring naturally is estimated at around 0.05%. That's 1 in 2,000. Again, not impossible. But it's another piece of the puzzle that doesn't quite fit. Third, the size and speed. Atlas is massive. Current estimates suggest its nucleus could be on the order of 5 kilometers across. To put that in perspective, that makes it roughly 1,000,000 times more massive than Oumuamua, the first confirmed interstellar object, and about 1,000 times more massive than 2I/Borisov, the second interstellar visitor. Yet despite this enormous size, Atlas is moving faster than both of those previous visitors. Large objects generally don't move this fast on interstellar trajectories. They require more energy to accelerate. The combination of extreme size with extreme speed is rare in the natural comet population. The probability of finding these characteristics together is estimated at less than 0.1%. Another unlikely data point. Fourth, the composition. This is where things get really strange. Spectroscopic analysis of the gas clouds surrounding Atlas revealed something unexpected. The object is releasing far more nickel relative to iron than any comet ever observed in our solar system. In natural cosmic environments, iron is typically more abundant than nickel, but here the ratio is inverted. Interestingly, this high nickel-to-iron ratio is common in certain types of industrially produced nickel alloys, the kind used in aerospace applications and advanced machinery. That's probably just a coincidence, but it's a noteworthy one. Even stranger, Atlas appears to be extremely dry. Water ice is the primary component of most comets. They're essentially dirty snowballs. But analysis suggests Atlas contains only about 4% water by mass in its vapor emissions, a comet that's 96% not water. That's unusual. What kind of comet forms without water? And if it's not a comet, what is it? Fifth, the polarization signature. When light reflects off Atlas, it exhibits extreme negative polarization. Without getting too deep into the physics, this means the orientation of light waves is being flipped in a way that hasn't been observed in any other comet. Even 2I/Borisov, the previous interstellar comet, didn't show this behavior. The probability of this occurring randomly due to normal cometary properties is estimated at less than 1%. It's another subtle indicator that something about this object's surface material or structure is fundamentally different from what's expected. Sixth, and perhaps most eerie, is the directional origin. Atlas entered the solar system from a region of sky that's within approximately 9 degrees of the source of the famous WOW signal. The WOW signal was a strong narrowband radio signal detected in 1977 by the Big Ear radio telescope. It lasted 72 seconds and has never been detected again. Many researchers suspected it could have been a transmission from an extraterrestrial intelligence, though no confirmation was ever obtained. The fact that Atlas comes from nearly the same direction decades later could be pure coincidence. The probability of this alignment is estimated at around 0.6%, but given everything else, it's hard not to wonder. Seventh, the brightness behavior. As Atlas approached the Sun, instead of disintegrating or fragmenting like many comets do under intense heat, it became dramatically brighter. Not just brighter in the expected way from increased solar illumination, but brighter by a factor that exceeded predictions. And as mentioned earlier, it also shifted color, becoming bluer rather than redder. A comet that brightens unusually and changes color in the wrong direction is virtually unprecedented. And now, eighth, the missing tail. The object exhibited non-gravitational acceleration strong enough to require losing 10 to 20% of its mass, yet there's no corresponding tail, no visible debris field, no extended coma, nothing. When each of these anomalies is considered individually, explanations can be proposed. Unusual but not impossible. However, when all of them are taken together, when the statistical improbabilities are multiplied, the cumulative odds become extraordinarily small. Some estimates place the probability of one object randomly exhibiting all of these characteristics at approximately 1 in 10 quadrillion. That's a 1 followed by 16 zeros. For practical purposes, that's essentially impossible. So what's the alternative? What explanation could account for all of these observations simultaneously? This is where the conversation becomes uncomfortable for many scientists, because the alternative that keeps emerging is that Atlas might not be entirely natural. Or at least, not natural in the way comets are typically understood. Dr. Avi Loeb, the Harvard astrophysicist who has been among the most vocal advocates for taking these anomalies seriously, has suggested that the possibility of technological origin should not be dismissed without investigation. That doesn't mean Atlas is definitely artificial. It means the data warrants serious scientific inquiry rather than reflexive dismissal. If Atlas were a probe or some kind of manufactured object, many of the anomalies would make more sense. The precise orbital alignment could be intentional navigation. The timing that minimized Earth-based observation during perihelion could be deliberate. The unusual composition could reflect construction materials rather than natural accretion. The extreme negative polarization could result from engineered surfaces. The acceleration without visible exhaust could indicate propulsion technology rather than outgassing. And the missing tail, despite mass loss, could mean that whatever is being expelled is not the type of debris a comet would produce. This is speculation, of course, but it's speculation grounded in observational data that doesn't fit standard models. The question isn't whether these ideas sound like science fiction. The question is whether the observations can be explained by conventional comet physics. And increasingly, the answer appears to be no. More data is coming. Atlas will reach its closest approach to Earth on December 19th, just 6 days before Christmas. At that point, observatories around the world will have their best opportunity to study the object in detail. High-resolution spectroscopy, thermal imaging, radar observations if possible, every available instrument should be pointed at this visitor, because the implications are profound. If Atlas turns out to have a natural explanation, if some exotic formation environment or unusual composition can account for all the anomalies, that's valuable knowledge. It would expand understanding of planetary system formation and the diversity of objects in the galaxy. But if the technological hypothesis cannot be ruled out, if the evidence continues to point towards something artificial, then humanity is facing a moment of historic significance. Contact, even indirect contact in the form of an uncrewed probe, would represent confirmation that intelligence exists beyond Earth. And given that Atlas is traveling at roughly 3 times the speed of our fastest spacecraft, and given its size, which is larger than anything humanity has ever launched, there would be nothing current technology could do to intercept or interact with it. For now, the scientific approach is clear. Gather more data, remain open to all possibilities, avoid speculation without evidence, and most importantly, take the observations seriously. When an object moves like a comet, thanks to measurable acceleration but looks nothing like one, when it lacks the fundamental features that define comets, that's not a mere oddity. It's a signal that current categories may be insufficient. The term comet might not apply here, not because the data is weak, but because the category is too narrow. The threshold isn't just seeing the anomaly, it's deciding what to call it, and what that decision means for how humanity understands its place in the universe. The coming weeks will be critical. Atlas is approaching, and whether it's a natural marvel or something else entirely, the answers are getting closer.